In 3 days, an interstellar object will reach its closest point to Earth. We still don't know exactly what it is, and some of its behaviors have never been observed before. This is not speculation. It is not a theory. It is a statement based on current data. The object is known as 3I/ATLAS. It entered our solar system from interstellar space, meaning it did not originate here. It is only the third confirmed interstellar object ever observed passing through our system after Oumuamua and Borisov. That alone already makes it rare. But what makes 3I/ATLAS different is not just where it comes from, it's what it's doing. When 3I/ATLAS was first detected, astronomers did what they always do. They measured its speed, its direction, and the gravitational influence of the Sun, then calculated its trajectory. According to those calculations, the object should follow a simple hyperbolic path. Enter the system, curve around the Sun once, and leave forever. A one-time visitor. But new data changed that picture. Over the past weeks, orbital calculations began to show a persistent deviation. Small, but consistent. The object was not following the exact curve predicted by gravity alone. This phenomenon is known as non-gravitational acceleration. It is not unheard of in comets, but what matters here is not its existence, it's its behavior. In typical comets, non-gravitational forces come from outgassing. Ice heats up, gas escapes through random vents, and the object wobbles. The thrust is chaotic. The orientation changes. The effect varies. That is not what we are seeing here. For 3I/ATLAS, the acceleration appears smooth, predictable, stable over time. This strongly suggests that the object is not tumbling randomly. Instead, it appears to maintain a relatively consistent orientation while producing thrust. This alone does not prove anything exotic. There are natural explanations. Shape, rotation, internal structure, and uneven heating could, in theory, combine to produce such behavior. But this is only the first layer. As observations continued, the morphology of the object began to change rapidly. High-resolution images taken only hours apart revealed noticeable differences. What initially looked like a diffuse, elongated cloud around the nucleus evolved into a more organized structure. A faint but coherent spiral pattern appeared, wrapping outward from the core and feeding directly into the main tail. This is not typical flickering. This is structured evolution. Photometric data reinforce this picture. The light curve, the way brightness changes as the object rotates, became more complex. In addition to the primary brightness variation, a secondary, repeating pulse emerged at a fixed phase. This usually indicates a new, persistent active region on the surface. In other words, something new turned on, and it stayed on. At the same time, spectroscopic measurements showed subtle but important changes in composition. Lighter, more volatile compounds began to fade, while signatures associated with deeper, more resilient materials became stronger. Larger dust grains increased. This tells us that surface layers are being stripped away, exposing interior material that had never been heated before. All of this points to a single conclusion. 3I/ATLAS is not simply fading as it exits the inner solar system. It is evolving, actively, layer by layer. The physics behind this could be explained by thermal propagation. Heat absorbed near perihelion continues to move inward, activating deeper pockets of material days or weeks later. Each activation opens new vents, alters the jet structure, and changes the forces acting on the nucleus. But here again, the details matter. As new vents appear, the non-gravitational acceleration has not become more chaotic. It has become more regular. The thrust is aligning. The system is, at least temporarily, stabilizing into a new configuration. This creates a delicate and potentially dangerous situation. You now have a body under sustained directional stress, while its internal structure is being progressively weakened by thermal fracturing. In simple terms, it is being pushed while it is cracking. There are two possible outcomes. Either the object settles into a new stable mode and leaves the system intact, or the accumulating stress exceeds its structural limits, leading to fragmentation. We do not yet know which path it will take. Another important aspect is debris. 3. I/ATLAS is releasing material, including relatively heavy particles. Fine dust is quickly blown away by solar radiation. Heavier grains are not. They remain gravitationally bound to the sun and can form long-lived streams. Calculations indicate that some of this debris will intersect Earth's orbital path in the coming years. Not the nucleus itself, but its remnants. This is not dangerous in the immediate sense, but it is significant scientifically. The object is not just passing through, it is leaving traces behind. Now we arrive at December 19th. On that date, 3I/ATLAS will reach its closest approach to Earth at roughly 1.8 astronomical units. Still far in human terms, but close enough for our most powerful instruments to observe it under optimal geometry. Illumination angles will improve. The coma may thin. For the first time, we may be able to see the nucleus itself. This is critical. Comet nuclei are usually irregular, jagged, and chaotic, loose aggregates of ice and rock. If the nucleus of 3I/ATLAS appears similarly irregular, it would strongly support a natural origin. If, however, the object shows an unexpectedly smooth, symmetric, or geometrically coherent shape, that would be deeply anomalous. Rotation measurements will also matter. A fast rotation could help explain stable thrust. A slow rotation would make such stability extremely difficult to justify with known natural mechanisms. Finally, there's the question of trajectory adjustment. If any additional change in acceleration occurs near closest approach, when external gravitational influences are strongest, it will be measurable. If that change follows predictable outgassing models, the case closes. If it does not, the discussion changes. At this point, several scenarios remain on the table. The first is that 3I/ATLAS is a natural but rare type of interstellar comet, exhibiting behaviors we simply haven't observed before due to limited data. This is the conservative position, and it may ultimately be correct. The second is that it plays a role in interstellar panspermia, the transport of organic compounds across star systems. Its chemistry supports this possibility, and its debris could remain in our system for thousands of years. The third scenario is the one nobody wants to state outright, not because it is proven, but because it cannot yet be excluded. If you wanted to design a long-duration interstellar probe, you would protect it with ice, use stellar gravity for maneuvering, rely on subtle thrust mechanisms, maintain orientation, release material into stable orbits, and make it appear natural to avoid detection. 3. I/ATLAS exhibits elements that resemble that profile. Does that mean it is artificial? No, but it does mean that, as of today, no single natural explanation fully accounts for all observed signals at once. And that is the uncomfortable truth. In 3 days, we will see more clearly than ever before. This may resolve the mystery, or it may deepen it. Either way, 3I/ATLAS represents a reminder of how little we truly know about what passes through our cosmic neighborhood. This is not about fear. It's about humility. We are watching an interstellar object change in real time. And for now, we are still guessing why. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.